because it was the first time. A lot of mistakes. You got attendance, right, Mr. Parker?
Yes, sir.
Okay. All right, so we talked about slope-intercept form. All right, take a look at that next one. Those first ones, they just tell you, like, boom, slope is that, y-intercept is this. So you just stick it in that form, nice and easy. These next few, got to do a little bit of extra. Do you know, Jeff, look at it, real close. Do you know the y-intercept?
The -3.
Yeah, it's -3. It hits the y-axis. So it tells us the y-intercept. It is -3. Does it tell us the slope? Does it just say this is a slope? No, but can you figure out the slope? Yeah. You got 2 points. We do rise over run. It'll be a fraction, but we might need to reduce it. So we're going to go up, and then you go over. So you can go right up. Now, how far up do we go? How far over? Juan, what do you think? 6 up. 1, 2, 3, 4, 5, 6 up. And then 1, 2, 3, 4 over. All right, so my slope. Now, is it positive or negative, Juan? Positive, good. So my slope is 6 over 4. The only thing you have to do is you got to reduce that. You can't 6 over, and do not write it as a mixed number. Because if you hit 6 over 4 in your calculator, I don't have my calculator, it'll probably say 1.5. We don't want that.
Yeah, guys, remember on that first page with that slope formula, remember no reduced fractions and no decimals or mixed numbers. We want to see our rise over run.
And so, like, if you just hit 6 divided by 4, it'll say 1.5. Like, so we don't want that. Now, there's ways you can hit that, ABC button or different things, but you should be able to figure out this. What does that reduce to? 3 over 2. 3 over 2. 3 over 2. So now that is 3 over 2. All right, final answer, though. I write each line in slope-intercept form. So final answer, what do you think, Damian Burnett? 3/2 x minus 3. Good. Make sure you have a number in front of that x. Make sure you have a minus. Make sure you have an x. Make sure you have a minus 3. All right, so that's going to be y equals 3/2 x minus 3. So I started -3. You can go up 1, 2, 3, and over 2, and it'll hit that line again. Okay, see how that reduces? And then I can go up 1, 2, 3, over 2. That's a 6/4 is the same as 3/2. All right, number 2. And you got this here. Okay, just looking at that line. Maddie, what is my y-intercept? 2. Y-intercept is 2. Slope, which we label M. There's a reason, but I forget why.
I don't know.
You know, why we didn't say S?
Wasn't it for something like Greek, something like French?
Yeah, something I had to do. We'll have to look it up.
I think I put Westfall on it one time. I asked him.
There we go.
He said something about the word in French, I think.
Okay, that might be it. So, Emily, what's your slope? What do you think?
3 over 4.
Positive or negative?
Positive.
Going down. So it's negative. So that's the key. It's not going to tell you. So I'm just going to make it -3/4. When you go down, you need to know by the slant of the line. But when you go down, you're really going down from 2 to -1. That would be -3. Like if you think of the y value, it's at 2 here, it's at -1 there. That would be -3. Here, my x value is 0. My other x value is 4. That would be a +4. So going down is negative, going right is positive. So that's another way to think about it. So it would be -3/4. Aiden, what should be my answer then?
Y equals -3/4 x plus 2.
Good. Y equals -3/4 x plus not 3, but 2. For that. All right, now it says write an equation of the line that passes through each pair of points. They're going to give us a pair of points. So first time they just said, here's this y-intercept, here's your slope. Boom, you wrote it down. Second time, here's a picture. Okay, from the picture, give me the slope, give me the y-intercept. Third way, I'm just going to give you 2 points. All right, find the slope. How do we find the slope between 2 points? Zach, you remember?
y2 minus y1 over x2 minus x1.
Difference of the x's over the difference of the y's. So I'm going to write this down. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, I want you to take a look. Before you write anything down, I want you to think, what order are you going to subtract? Okay, what order are you going to subtract to figure that out? Alex, what do you think?
-1 minus 5 and then 0 minus -3.
0 minus -3. Good. Now, the only thing you got to watch is your signs. So be careful. He's perfectly good. He's like the second. Now, there's always the y's on top. So -1 and 5, give me my y's. And then 0 and -3, give me my x's. So what's -1 minus 5? All right, what's that give me? Addie?
-6.
Good, -6. And what is 0 minus 3?
30.
And then what's -6 divided by 3?
-1.
Ooh, no,
Or 2.
-2. All right, can anybody give me the final answer? What is that equation, slope intercept point? Ellie?
Y equals -2x.
But what's the y-intercept? Got to have that as well.
-1.
All right, he says -1. He says -1. He's correct. So you got to have the slope, you got to have the y-intercept. All right, where'd that come from? Jeff, you any idea?
Not really.
All right, let everybody look at it. You got it. You got it. Let everybody else look at it. Where's it coming from? Okay, just Eric, Carly, you know where it comes from? No? Oh, man. Gavin?
Is it from one of the y-intercepts up there?
Which one's the y-intercept?
The -1.
Okay, right here, this point. Let me erase this for a second. That point right there is the y-intercept. If the x-coordinate is 0, okay, if the x-coordinate is 0, it is our y-intercept. Because think about this. If I were to plot this on an x and y axis, 0, -1 would be right there. And then -3, 5. And you don't have to. This is what we're doing. We got that line through there. That tells me the y-intercept. Okay, that tells me the y-intercept. Only if you have a 0 in the x-coordinate. So right there, we got to figure out the slope. We got the y-intercept. So we're good. All right, the second one. Does it give us the y-intercept? As you take a look at that. Okay, Mason, what do you think?
Um,
Okay, look over here. What was the characteristic of this one? I said this one's the y-intercept. What is its x-coordinate? The x-coordinate's the first one.
Oh, 0.
Okay, do you have a point over there that has 0 in the x-coordinate? Yeah. So right here, that says 0, -5/8. That means your y-intercept is that y value, which is -5/8. Or not 5/8, -5.8. So that is your y-intercept. We got that. Got to figure out the slope though. Got to figure out the slope. So m equals y2 minus y1 over x2 minus x1. And so, all right, tell me what order to subtract. All right, Ellie.
-5.8 minus -5.8.
Good. -5.8 minus -5.8 over, what should be over?
8 minus 0.
8 minus 0. Okay, so now, take a look, be careful. What's that give us?
11.6 over 8.
Ooh, not 11.6. Nope.
What happens if you subtract the
What's
negative?
that?
2 negatives make a positive.
Yep, so that should be -5.8 plus what? 5.8. And what's that give us? Negative 5.8 over 5.8 is going to actually give us 0. 0 over 8 is 0. So now you got y equals 0x minus 5.8. All right, that's the first step. I don't want that as the final answer because what can that just become?
Y equals negative 5.8.
Make sure this is your final answer. Negative 5.8. Make sure that's your final answer. Okay. All right, you try number 3. You try number 3. See what you come up with.
Is that correct?
It is. It is. Guys, do we know? You always want to check first. Do they give us any information? Do they give us the y-intercept?
Y-intercept is negative 6.
Y-intercept's negative 6. Guys, that's going to save us a lot of work. Okay? The y-intercept is negative 6. Okay? Just negative 6. All right? Now, how am I going to set up to get the slope? Go ahead.
9 minus negative 6 over 3 minus 0.
Good job. What happens here? Plus, plus, what's it go to?
15.
15 over
3.
3, which is what?
5.
5. Okay, so here's our slope. So go ahead, Ellie, tell me what you got.
Y equals 5x minus 6.
All right, how'd you guys do? Did you guys do okay? Oh.
All right, now they're throwing this at you. They said write a linear function with the values f of 0 equals 10 and f of 6 equals 34. So we're on the back. Now, that's really just 2 points. It's no different than what you just saw. They just give it to you in a different format. Here they give you 2 points. We just did that. But now they say f of 0 equals 10. This means when I plug in 0, I get back the answer 10. That's the point 0, 10. So write that down. And I don't know what the function is, and I don't need to know it. I just know when I plug in 0, I get back 10. I know when I plug in 6, I get back 34. I know that. Okay, I know that. So now, it's the same thing. It's the directions still say write a linear function. All right. Now, the only difference between that is we got y equals mx plus b. When we are done, I'm just going to make it f of x equals mx plus b. We'll get there in a second. I still got to find the slope. Find that. So we do m equals subtract 34, bless you, minus 10 over 6 minus, bless you,
There you go.
over 6 minus 0. So I want to do that. 34 minus 10 over 6 minus 0. All right, 34 minus 10. Lindsay, what are we going to get? I see you back there working on it.
24.
24. 6 minus 0, what's that? And what is 24 divided by 6? Lindsay?
4.
4. All right, so good. All right, now, first of all, what is my equation with y equals? Mason. All right, you good here? You got that? All right, what do you think I should put down for my equation?
Y equals 4x plus 10.
Plus what?
10.
Plus 10. Good, because this right here, that's 0, 10. That is your y-intercept is 10. Now, just like a minor detail, and I said earlier, when they tell us this, write a linear function. That's always f of x. So the only thing you're going to do is you're going to take that y out and make this f of x equals 4x plus 10. Okay, that's all you're doing. Y equals 4x plus 10. So is it any different? No. 2 points, find the slope, write the equation. So exact same thing. F of 0 equals 9, f of 8 equals 7. And so I got 2 points. I'm going to write those as 2 points. 0, 9, and 8, 7. All right, now I'm curious to see what you write down for your slope. Figure out your slope. Okay, then just hold for half a second. Make sure that's correct. So figure out your slope. Make sure we go in the right order. Okay, now it reduces. That'll reduce.
You did 9 minus 7. You gotta do the same order. You gotta do 0 minus 8.
I moved it to, I think this is 28. Is that it?
Yep. Thank
Okay, all right, good.
Because what happens is negative 8. Now, do you know how to do something? We'll try it. See if okay, no, yep. Oh, you do it. All right, here's the deal. A positive divided
Patty, set the slope up. What'd you write?
I did
It'll always give you
7
an
minus
error
9,
message.
I like it.
and then 8 minus 0,
I like
You
it.
know it's gonna be negative, so just do
and then I got negative 2 on top,
Negative.
8 on the bottom,
Okay, now what does that reduce to?
negative 4.
Okay, how'd everybody do on that? How'd everybody do on that? Negative 1/4? Okay, so let's write it slope-intercept form. Now, do I have my y-intercept?
Yes.
Yeah, right here, right? So somebody give me that in slope-intercept form. Go ahead.
F of x
Okay, you want to? Okay, I was going to change it, but we can go f of x right now. Same as y, right? Go ahead.
equals negative 1/4 plus 9.
Careful. What'd you forget?
Negative 1/4 what?
X plus 9.
Hey, now take a look at this. Make sure you understand what's going on here. F of x equals negative 1/4 x plus 9. What should you get when you plug in the number 8 into that function? What should you get when I plug in 8, Ava?
7.
I better get 7 if I did everything right. So what that means is f of 8, if I plug that in, negative 1/4 times 8 plus 9, well, negative 1/4 times 8. Anybody know what that is? Or use your calculator? Negative 1/4 times 8 gives me, Maddie?
Negative 2.
Negative 2. And then what's negative 2 plus 9? 7. So that means when I plug in f of 8, when I plug in 8, I get back 7. That better happen. When I plug in 0, I better get back 9. Okay, so we're finding this function that gives us these points. All right, let's take a look at something that can be modeled by a linear equation. Okay. So a linear model is a linear function that represents a real-life situation. When the quantity y changes at a constant rate, okay, something changes at a constant rate, you can use the equation y equals mx plus b to model the relationship. Okay, the value of M is the rate of change, which is still our slope. Rate of change. It is going to be the same as our slope. Okay, anything that is increasing or decreasing. So if you are increasing your speed at a constant rate of change, it's going to be your slope. B is the initial or starting value. Initial, I got to learn how to spell. Initial or starting value. It's still our y-intercept, but it's just where we start at. So M, that rate of change. Okay. B, that initial or starting value. Now, it'll make hopefully a little more sense here as we take a look at this example. Helen's in a bicycle race. She's already biked 10 miles and is now biking at a rate of 18 miles per hour. Her distance as a function of time is shown in the graph. All right, write an equation that represents the distance Helen has biked as a function of time. So put a letter A underneath there. All right, now think about it. Don't write anything down here, but just think about it. What would that look like? Griffin?
I had a question.
Go ahead.
So, you said the rate of change has to be constant, but if she's changing how fast she's going,
Well,
like 10 miles into the race, isn't that not a constant rate of change?
all right. What is the 10 referring to? The 10 is saying she has. Well, that's not a rate. The 10 is not a rate. What is that? It's just.
No, but I'm saying that she already has done that, and now she's changing her speed to 18, and that's not a constant rate.
The 8. All right. We don't know what rate she was biking to get that 10 miles. So basically, after she's done 10 miles, she will be biking at a constant rate of 18 miles per hour. I'm not sure what happened before that, but that's going to be a little bit irrelevant in this case because we know at this point, from here out, she's going 18 miles per hour. That's your constant rate of change. Gavin, what do you think the equation would be?
Um, 18x plus 10.
Okay, yep. Just you've got to put down y equals. So y equals 18x plus 10. That would be that. So now we talked about in this last slide, M is your rate of change. Okay, your slope is your rate of change. And they said the rate of change in this case would be miles per hour. B is your initial or starting value. All right, look at B. Identify the slope and y-intercept and describe their meanings. Okay, and they really, if you just read it at the top, it gives it to you. I mean, it really, in this case, it just kind of tells you. All right, so my slope, make sure we identify. So Addie, what's my slope?
10
Oh, no.
or 18.
Slope is always a number in front of the x.
18.
18, and it's always shit. And what does it represent in this case?
The miles she's biking per hour.
Okay, that's her rate, so it's miles per hour. So she's biking at a rate of 18 miles per hour. She's biking at a rate of 18 miles per hour. Okay. Slope is a rate of change. Rate of change. All right, y-intercept. Damien, what's our y-intercept? 10. What does that represent? Okay, if you read up there, it kind of tells us it's the number of miles she's already biked. Okay, before she kicks into 18 miles per hour. Okay, amount of miles she's already biked. Okay, so now take a look at that last one. C. Find the how far will Helen have biked after 2 hours? Okay, after 2 hours. Griffin?
I just said like 46.5 or 47 miles.
Okay, that's looking at the graph. So the graph you're kind of estimating. So you're going here. How can I use the equation to find the exact value? Okay, use that equation to find the exact. Lucas?
Plug 2 in for X.
Yep, we got y equals 18x plus 10. Plug in x equals 2. And when I do that, I get y equals 18 times 2 plus 10. And that's 36 plus 10, so that's 46 miles, which should match up with you look at the graph. Okay, so sometimes on the graph, like it's hard to pinpoint exactly. If I have an equation, I need to use that. Okay, I need to use that. All right, you should be good there. This is just a good old-fashioned paper and pencil assignment, not on your computer. Those of you who have not turned in on that online or were absent, I already talked to Mason Griffin. You have your computer out, Natty. I want you to see it on there too. Okay, so you just get that. Okay. All right, go ahead. You got some. You got a little bit.
Kevin's got a couple more for computer.
Oh, okay. Oh, you give that.
You and a girl. That's this.
He's so good.
I didn't turn mine in yet because I didn't get it finished. It wasn't working last week. So should I just
At all?
I
Is it
have-
working now?
Uh,
Pull it out.
Where did I say that?